We are starting paper 3 for mid-year exam of Beacon House. The year is 2024. Total marks is 75 and the total time there is 1 hour 50 minutes. We are going to solve each and every question one by one. Question number 1, part A. Sketch the value of y is equal to x minus 2a, where a is a positive constant. The second part of this one is solve the inequality 2x minus 3a is less than x minus 2a. Question number 1. Draw the sketch of y equal to x minus 2a modulus, where a is a positive constant. Because we are drawing only the sketch of this, and here it is a linear equation, which means if it is x-axis, this is y-axis, then it is minus sign there, so it is going towards the right side, 2a, and this is the graph of y is equal to x minus 2a whole modulus there. Then the second part of this thing is solve 2x minus 3a is less than x minus 2a modulus. Now, since it is the solution of this equation is there are three methods, and I will explain you that why the other two methods are going to failure in that part. We know one thing, that x modulus is basically equal to x square and then square root, or it is equal to plus minus x. The method A there is when we draw with this property plus minus x. So 2x minus 3a is less than x minus 2a modulus there. So 2x minus 3a is less than plus minus x minus 2a. So there is two options, plus and minus there. So if we take 2x minus 3a is less than plus x minus 2a, then shifting it on one side, x is less than a. This is one solution of this problem there. The second problem is there is that if we use the negative values, 2x minus 3a is less than minus x minus 2a, then 2x minus 3a is less than minus x plus 2a, or 3x is less than 5a, or x is less than 5 over 3a. Let's say that is the second answer of this part. So x is less than a and x is less than 5 over 3a, since a is less than 2a value. So that is why the solution of this problem is x is less than 5 over 3a. Now, we will confirm it with the other two methods there, that why they are rejected. Second method is we use the squaring method of this. Then this will become 2x minus 3a is less than 2x minus 3a. So the x minus a whole square and then square root. Taking square on both sides, 2x minus 3a whole square is less than x minus 2a whole square. We open it, it will become 4x square minus 12ax plus 9a square is less than x square minus 4ax plus 4a square. Shifting it on one side, this will become 3x square minus 8ax plus 5a square is less than 0. We use the critical solution for this, which means that this less than or equal to will become equal to 0. So minus 8x plus 5a square is equal to 0. If we factorize this will become 3x square minus 3x minus 5x plus 5a square equal to 0. In between these two, 3x is common, so x minus a, and between these two, minus 5a is common, so x minus a is equal to 0. Or x minus a into 3x minus 5a is equal to 0, then x will be equal to a or 5a over 3. If we draw the inequalities on this number line system of this graph there, then it is 5a over 3. So coefficient of this one is positive. So the shape will be minima, and it is because less than 0. So that means this portion will be eliminated there, shown there. So x is greater than a, less than 5a over 3. But here we are showing it x is less than a, and this is showing x is greater than a. So it means they are going to contradict each other. This second part is x is less than 5 by 3a. It is true there, x is less than 5 by 3a. So the first part is x is less than a, and here it is x is greater than a. So we are going to reject this option for the solution of this inequality there. Then the third method, which is the sketch of this graph, is this is x-axis, this is y-axis, and here it is 0, it is a, it is 2a. So this is the graph of this y equal to x minus 2a modulus for this. And the second graph is shown there. Let y is equal to 2x minus 3a, because slope is positive, so it will be drawn from the first towards the third quadrant, and 3a is negative, so it will be passing from this. So this is the value which we are going to show it on this part there. And here they are going to meet each other. But this point of meeting there is denoted by 5a over 3. So from this point, this graph is above than this line there, which is shown it there, that 2x minus 3a is less than x minus 2a. So it is less than this value there. So this value will be accepted there. So the final answer is x is equal to 5a over 3. This is the actual answer of this question there. So basically, whenever it is given in the form of the inequalities, and there is one side, the modulus, and the other side is the function, then you have to find out the solution with the inequality concept, with the sketch of this graph. That is giving you the final solution of this problem there. So always draw the sketch whenever you are going to use the equation in the form of the linear equation, and the other is the modulus of that equation there. Question number 2 now. Express 6x square minus 9x minus 16 over 2x square minus 5x minus 12 in the partial fraction. Since we know that that in the numerator highest power is 2, in the denominator highest power is 2. We know that whenever numerator power is greater than or equal to denominator power, then you are going to use the fraction part of this with the division method there. Then this equation will become 6x squared minus 9x minus 16 divided by 2x squared minus 5x minus 12 is equal to quotient of x plus remainder in terms of x over divisor in terms of x. Let's say it is equation number 1 there. So because it is going to divide, so first of all 6x squared minus 9x minus 16 is divided by 2x squared minus 5x minus 12. So it will be 3 there. 6x squared minus 15x minus 36. If we subtract the lower part from this main equation, then this 15x minus 9x is 6x plus 36 minus 16 is plus 20. So the equation number 1 will become equal to 3 plus 6x plus 20. This is the remainder there. This is the divisor there. And this is the quotient there. Over 2x squared minus 5x minus 12. Let's say that is equation number 2. But since the denominator is in quadratic form, so we are going to factorize this denominator into the parts. So 2x squared minus 5x minus 12, 2x squared minus 8x plus 3x minus 12, that is equal to 2x is common, x minus 4 plus 3 is common, x minus 4. So this will become x minus 4 into 2x plus 3. So our expression 1 will, this 2 will become a part of this one will be 6x plus 20 over x minus 4 into 2x plus 3. Because in the denominator, both parts are in the linear form. So, and they are distinct. So that is why we are going to use this method a over x minus 4 plus b over 2x plus 3. Let's say that is equation number 3. Then 6x plus 20 is equal to a into 2x plus 3 plus b into x minus 4. Let's say that is equation number 4 there. We are basically want to get the values of a and b in this part. So for a, put x minus 4 equal to 0. This implies that x is equal to 4 in equation number 4 there. So this will become 6 into 4 plus 20 is equal to a into 4 2s are 8 plus 3 plus b into 0. So 24 plus this is 44 is equal to a into 11. So a value will be equal to 4 there. Then we put for b 2x plus 3 equals 0. This implies that x is equal to minus 3 over 2 in equation number 4. So 4 will become here 6 into minus 3 over 2 plus 20 is equal to a with 0 and b with minus 3 over 2 minus 4. So this is minus 9 plus 20. 11 there is b. 2 fours are 8 minus 3 minus 11 over 4. 11 over 2. So b value is equal to minus 2 there. Now we put the values of a, b into this equation number 2 there. So 2 will become final equation of this one is 3 plus 4 over x minus 4 minus 2 over 2x plus 3. This is the final solution of this problem there. Now we are starting question number 3. The values x, y satisfy this equation a power 2y minus 1 is equal to b power x minus 1, where a and b are constants. Show that the graphs of y against x is a straight line. Since we are going to show it in a straight line and the variables are lying in the power, so you are taking the log on both sides. We know that taking log on both sides, a log of a power 2y minus 1 is equal to log of b power x minus 1. With the help of this property, log of a power b is equal to b log of a. We can expand it as 2y minus 1 log of a is equal to x minus 1 log of b. Now we will multiply 2y log of a minus log of a is equal to x log of b minus log of b. This will become y into 2 ln of a is equal to ln of a plus x ln of b minus ln of b there. Then this will become y into log of a square is equal to log of a minus log of b plus x log of b there. Now divide it on both sides by log of a square. Log of a over b is basically equal to log of a over b plus x log of b, dividing it on both sides by log of a square and here log of a square. So this will become y is equal to log of b over log of a square into x plus log of a over b whole divided by log of a square. So that is going to represent this y is equal to mx plus c, where m is this and c value is this, and it is the linear equation which is going to be represented by this equation there. Given that a is equal to b cube, state the equation of the straight line in the form of y is equal to px plus q, where p and q are the rational numbers in the simplest form. So b part, a is equal to b cube. This is given there. So we have this equation a is equal to 2y minus 1 is equal to b power x minus 1. But since a is equal to b cube, so we can write b cube power 2y minus 1 is equal to b into x minus 1, or b will be equal to 6y minus 3 is equal to b power x minus 1. Taking log on both sides, log of b power 6y minus 3 is equal to log of b power x minus 1. So 6y minus 3 log of b is equal to x minus 1 log of b. So log of b and log of b are going to be cancelled out. So 6y minus 3 is equal to x minus 1, or 6y is equal to x plus 2. So y will be equal to x over 6 plus 2 over 6, or y is equal to 1 over 6x plus 1 over 3. And from this, y is equal to, is going to be presented in the form of px plus q. So from this equation 1 and 2, p value is equal to 1 over 6 and q value is equal to 1 over 3. Now question number 4. The equation of this curve is y e power 2x plus y square e power x is equal to 6. Find the gradient of the curve at the point where y is equal to 1. Since at the we are finding the gradient, which means dy by dx, where y is equal to 1. So let's put first y is equal to 1 in this equation. So this will become 1 into e power 2x plus 1 square into e power x is equal to 6, this will become e power 2x plus e power x is equal to 6. This will become e power 2x plus e power x minus 6 is equal to 0. But this is not a quadratic equation. It is in terms of the e power there. But we have seen it there that one power is half of this power is double of this power. So we suppose let e of x is equal to k, then e power 2x is equal to k square. So this equation number 1 will become k square plus k minus 6 is equal to 0. Factorize this. So k square, 6 factors are 2, 3. So 3k minus 2k minus 6 is equal to 0. K is common. K plus 3 minus 2 is common. K plus 3 is equal to 0. Or k plus 3 into k minus 2 is equal to 0. So the value of k will be minus 3 and 2 there. But e power x is equal to k, and that is equal to minus 3, which is not possible because it is negative number. A negative number exponential is not possible. Then e of x is equal to k, which is equal to 2. Then x ln of e is equal to ln of 2, but ln of e is equal to 1. So x is equal to ln of 2. So the point there is ln of 2 and 1. Here we are going to find out the gradient of this curve at the point P there. Now we will use the differentiation, but it is an implicit function. So we cannot make implicit function means when we cannot make either x or y as a subject from the main equation. Then we use this implicit equation function. Then this will become on the product rule for y into e power 2x, y as it is into 2e power 2x plus e power 2x into dy by dx. Because wherever there is y, we use dy by dx for this part there. Plus y square. As it is into e power x, its derivative is 1 plus e power x as it is into 2y dy by dx is equal to 0. So these two terms are containing dy by dx. So we can write this thing as e power 2fx plus 2y e power x into dy by dx is equal to, we shift the rest on the other side, it will become minus 2 y e power 2 of x minus y square e power x, then dy by dx, which is the value of the gradient, will be equal to minus 2y e power 2 of x minus y square e power x over e power 2x plus 2y into e power x. Now we put the point P in this, which is log of 2 and 1. Then slope will be equal to dy by dx at the point P is equal to minus 2, y value is 1 into e power 2 ln of 2 minus y square is 1 square into e power x, that is e power ln of 2 divided by e power 2 ln of 2 plus 2, y value is 1 into e power ln of 2. But we know that this is minus 2 e power ln of 4 minus e power ln of 2 whole divided by e power ln of 4 plus 2 e power ln of 2. But e power ln of 2 is equal to 2. E power ln of 4 is equal to 4. Then dy by dx, which is equal to m, it is equal to minus 2 into 4 minus 2 divided by e power L is 4 plus 2 into 2. So this will become minus 8 minus 2 minus 10 divided by 4 plus 4 is 8. So final answer is minus 5 by 4 is the gradient of this equation there. Now question number 5. It is given that the equation e power 2x is equal to 5 plus cos of 3x has only one root. Show by the calculation that this root lies between the interval x greater than 0.7 and less than 0.8. Second part, show that if the sequence of this value in the interval from 0.7 to 0.8 given by the iterative formula xn plus 1 is equal to half ln of 5 plus cos of 3xn converges, then it converges to the root of this equation in the part A there. And third part, use this iterative formula to determine the correct root of this to the 3 decimal places given that the result of the each iteration is to the 5 decimal places. So these are the 3 questions regarding iteration method. So we are going to use one by one. Part 1. Since they say that it is converges to between 0.7 and 0.8, so first of all, let f of x is equal to e power 2x is equal to 5 plus cos of 3x, or f of x will be equal to e power 2x minus 5 minus cos of 3x. So f of 0.7, because it lies between 0.7 and 0.8, so for f of 0.7, e should be equal to e power 2 into 0.7 minus 5 minus cos of 3 into 0.7. And this numerical value, after being calculation, it is going to be equivalent to minus 0.439. Then f of 0.8 will be equal to e power 2 into 0.8 minus 5 minus cos of 3 into 0.8, and that value is equivalent to 0.690. Since f of 0.7 into f of 0.8 is less than 0, so we say that the root lies between 0.7 and 0.8. This is the first part of this question. The second part of this question is show that xn plus 1 is equal to half ln of 5 plus cos of 3xn. This iterative formula they have already shown to you. Now you have to prove it that this thing is going to be convergent to this formula number 1, e of 2x is equal to 5 plus cos of 3x. So first we are going to remove this subscript. So this will become x is equal to half ln of 5 plus cos of 3x. This 2 will be multiplied with this. So 2x is equal to ln of 5 plus cos of 3x. Then this ln will be removed. So e power 2x is equal to 5 plus cos of 3x. So this is the iterative formula which I have shown in the beginning there, that this is going to converge to this point there. And then the third, use this iterative formula to the 3 decimal places. Now, we know that the average of 0.7 and 0.8 is basically equal to, let's say it is x1, and that is 0.75. So x2 will be equal to half ln of 5 plus cos of 3 into x1, which is equal to half ln of 5 plus cos of 3 into 0.75, or that thing is equal to half ln of 5 plus cos of 2.15, and this value is equivalent to now we have calculated x2 there, which is half of 5 of cos of 3 into x1, and x1 value is 0.75. So that value is being, after calculation, is equal to 0.73579. Then x3 will be half ln of 5 plus cos of 3x2, and x2 value is 2.12. So their value is equal to 0.74939. x4 value will be equal to 0.73775. x5 value will be equal to 0.74089. x6 value will be equal to 0.7400 there. But because the answer is required up till 3 decimal places, so it should be answer equal to 0.740. Now we are starting question number 6 of this. The diagram shows a curve y is equal to x into e power ax, where a is a constant and it has a maximum point m. Find the exact coordinates of m. Since m is the turning point of this curve, so you are going to find out dy over dx, and it is equal to 0 because at the m point it is parallel to the x-axis, which means it is a turning point. So we have to find out dy by dx equal to 0. So here y is equal to x e power minus a f x, So dy by dx is equal to, it is a product rule between the two functions x and e of ax. So e of minus ax as it is, x derivative is 1, x as it is into minus a into e power minus ax. So that will be equal to e power minus ax into e power minus a of x, and that is equal to 0, or it is equal to minus e of ax common 1 minus ax equal to 0. So e of minus ax is not equal to 0 because it is exponential power of this. So 1 minus ax is equal to 0, or x is equal to 1 over a there. So the values of y there will be equal to x is 1 over a into e power minus a into 1 over a there. So y value is equal to 1 over a into e power minus 1, or it is equal to 1 over ae. So the coordinates of this point M there will be equal to 1 over a and 1 over a into e there. Next part is find the exact value of 0 to 2 over a of x into e power a of x into dx. This is the integration of this part, which is the product rule here. So we are using the integration by parts where u is equal to x. This means what? Du by d of x is equal to 1, and so here v is equal to x and du by dx is equal to e power e of x. So v is equal to x. This means dv by dx is equal to 1 and du by dx is equal to e power minus a of x. This means u is equal to e power ax over minus a. So by using this and putting into this equation, integral of v du by dx into d of x is equal to uv minus integral of u into dv by dx into d of x. This is integration by parts of this. So here it is equal to 0 to 2 over a x into e power minus a of x d of x is equal to u there, and u is there, e power minus ax over minus a into v, that is x, minus integration sign u, that is e of minus ax over minus a into dv by dx, that is 1 into d of x. So this will become minus e of minus ax over a into x. this minus minus plus 1 over a is outside into e power minus ax into d of x. So this will become equivalent to minus e of minus ax over a plus 1 over a, and the integration of this portion is e of minus ax over minus a, and the limits are given there 0 to 2 over a there. So this will become minus x e power minus x over a plus, and this minus minus 1 over a square into e power minus ax, and the limits are 0 to 2 by a. So first upper limit is 2 by a, so that is equal to minus 2 by a into e power minus a into 2 over a whole divided by a minus 1 over a square into e power minus a, x is 1, 2 by a minus 0, then this value will be 0 minus 1 over a square into e power 0. So this will be equal to minus 2 over a square into this a and a cancel out, e power minus 2 minus 1 over a square as it is. This a and a cancel, so it is e power minus 2 minus, this is 0 there, so this is e power 0 is 0, 1, so minus 1 over a square, and this is minus outside, so it will become plus 1 over a square. So this will become 1 over a square is common, minus 2 e of minus 2 minus e power minus 2 plus 1, or this will be equivalent to 1 over a square into minus 3 e power minus 2 plus 1, and that is the so it is like this, and if you take LCM as e square, then a square e square equal to e square minus 3. So this is the final answer of this integration of this x into e power minus ax with the limits from 0 to a there. Question number 7 now. The variables x and y satisfies this differential equation dy by dx is equal to x into e power y minus x, where y is equal to 0 and x is equal to 0. Solve this differential equation and obtain an solution for y in terms of x there. So y is equal, dy by dx is equal to x into e power y minus x when y is equal to 0 and x is equal to 0. Express y in terms of x. Since we have to separate the variables, dy over dx is equal to x into e power y into e power minus x. This will become dy over e power y is equal to integration x e power minus x into d of x. Then this will become e of minus y dy is equal to x into e of minus x d of x. This will become e power minus y over minus 1 is equal to, again we are using integration by parts. So this is v, this is du by dx. So according to the formula uv, so that is u is e power minus x over minus 1 into x minus integration minus x over minus 1, x derivative is 1 into d of x. This is become minus 1 over e of y is equal to minus x over e of x minus plus integration of e of minus x d of x. This is minus 1 over e of y is equal to minus x over e of x plus e of minus x over minus 1 plus constant of integration a, which is equivalent to minus 1 over e of y is equal to x over e of x minus 1 over e of x. So this will become e of x is common. It should be x minus 1 minus 1 over e of y there. This minus and minus with plus, so it should be equal to e of y is equal to e of x over x plus 1 by taking the reciprocal of these. Then taking the log on both sides, y ln of e is equal to ln of e of x over x plus 1. Since ln of e is 1, so y should be equal to ln of e of x over x plus 1 is the integration of this differential equation there. Then in the second part, find the value of y when x is equal to 1, giving your answer in the form of a minus ln of b, where a and b are constants. So here we are going to get the values of y in terms of this. So y itself equal to ln of e of x over x plus 1, where y is equal to, find out when x is equal to 1. So this will become y is equal to ln of e power 1 over 1 plus 1. That thing is equal to ln of e over 2, which is in the form of ln of e minus ln of 2 with the property of ln of a over b is equal to ln of a minus ln of b. So y is equal to ln of e is equal to 1 minus ln of 2, which is in the form of y is equal to a plus ln of b form there. So a is equal to 1 and b is equal to 2 there. So this is the solution of this problem for the question number 7 there. Question number 8 now. The points A, B, C have the position vectors OA is equal to minus 2i plus j plus 4k, OB is equal to 5i plus 2j, and OC is equal to 8i plus 5j minus 3k, where O is the origin and the line L1 passes through the point B and C. Find the vector equation of the line L1. Since this is passing from the point B and C, the equation is represented by the line L1. So L1 is R is equal to OB plus T times of BC because it is passing from the point B and C there. So R is equal to OB, that is 520 plus T times of BC, that is OC minus OB. So that is written as 520 plus T times of OC is 8, 5 and minus 3 minus OB, that is minus 5 minus 2 minus 0. So this will become 520 plus T times of 8 minus 5 is 3, 5 minus 2 is 3, and this is minus 3. Or you can even write this thing as 520 plus T times of, because 3 is common, so it should be equal to 1 minus 1, 1, 1 and minus 1. That is line L1, which is represented by this equation here. The second part of this is the line L2 is having the position vectors as R is equal to minus 2i plus j plus 4k. Plus n times of 3i plus j minus 2k. Find the coordinates of the point of intersection of the line L1 and L2. Since we are finding the point of intersection of L1 and L2, so L2 is represented by R, which is equal to minus 2, 1 and 4 plus n times of 3, 1 minus 2. Let's say that is equation number 2. Now we will make the pairs. From this L1, x is equal to 5 plus t, y equal to 2 plus t, and z is equal to minus t. L2 is going to say that x is equal to minus 2 plus 3n, y is equal to 1 plus n, and z is equal to 4 minus 2n. From these two equations, we have the point of intersection for that. There are x coordinates same. So we can write this thing as 5 plus t is equal to minus 2 plus 3n, or t minus 3n is equal to minus 7. Let's say this is equation number 3. Then we compare the equation of y there. It is 2 plus t, which is equal to 1 plus n, or this will become t minus n is equal to minus 1. Let's say that is 4. Now we will solve 3 and 4 simultaneously. It is t minus 3n is equal to minus 7. So here we are subtracting this. So t and t cancel out. Minus n plus 3n is 2n is equal to 7 minus 1, that is equal to 6, or n is equal to 3. So when n is equal to 3, then we know that t minus n is equal to minus 1. So t minus 3 is equal to minus 1, or t is equal to 2. Now we will check the point of intersection of these two by putting it in the third, where z is equal to minus t. So that is equal to minus 2. Because t value is there 2, so it should be equal to minus 2. So for this second one, z is equal to 4 minus 2 into n. 4 minus 2 into n value is 3 there. So that is equal to 4 minus 6, that is minus 2. So that means z coordinate is same. So they have a point of intersection is equal to x is equal to 5 plus t, but t value is there equal to 2. So 5 minus 2, that is equal to 3. Y value is equal to 2 plus t, 2 minus t value is equal to 2 there. 5 plus 2, 7. So here t value is 2 there. So 2 plus 2, that is equal to 4. And z value is already calculated there, which is equal to minus 2. So the point of intersection will be 7, 4, and minus 2 there. Then the third part of this one is the points D lies on the line L2 is such that AB is equal to BD. That is for the line L2 there. And you are going to find out the coordinates of the position vector of D. Since AB is OB minus OA is equal to BD is OD minus OB. So OD is equal to OB plus OB minus OA. OB is twice of OB minus OA. So 2 times of OB is already given to you 520 minus OA is there minus 2, 4 and 4. So this will become 5 2s are 10 plus 2, 12, 4 minus 4, 0, 0 minus 4 is minus 4. So that is the position vector of D there. Question number 9 now. The polynomial ax cube plus x square plus bx plus 3 is denoted by p of x. It is given that p of x is divisible by 2x minus 1 and that when p of x is divisible by x plus 2, the remainder is 5. Find the values of a and b there. So this is the equation and you are going to find out the values of a and b and then you are going to factorize this thing. So p of 2x minus 1 is the divisor because leaving the remainder equal to 0. So p of half should be equal to a into half cube plus half square plus b into half plus 3 that is equal to 0 or this will be equal to a divided by 8 plus 1 over 4 plus b over 2 plus 3 is equal to 0 or a over 8 plus b over 2 is equal to minus 3 minus 1 over 4. So here 8 is LCM. So a plus 4b is equal to 4 is LCM minus 12 minus 1. So 4 2s are 8. So we can write this thing as a plus 4b is equal to minus 13 into 2 minus 26. Let's say it is equation number 1. Then x plus 2 is leaving a remainder equal to 5. So p of minus 2 is equal to a into minus 2 cube plus minus 2 square plus b into minus 2 plus 3 and that is leaving the remainder equal to 5. So it should be equal to minus 8a plus 4 minus 2b plus 3 is equal to 5 or minus 8a minus 2b is equal to 5 and 4 plus 3 7 is minus 2 or we can take minus 2 as common. So 4a plus b is equal to 1. Let's say that is equation number 2. Now we have to solve 1 and 2 simultaneously. It is a plus 4b is equal to minus 26 and 4a plus b is equal to 1. So from this we can make b as a subject. It should be 1 minus 4a. Put it into the 1. So a plus 4 into 1 minus 4a is equal to minus 26. So a plus 4 minus 16a is equal to minus 26. So a minus 16a is minus 15a plus 4 is going to this side, which is minus 30. So a value is equal to 2 there. And b value is equal to 1 minus 4a. So that is 1 minus 4 into 2 or 1 minus 8, that is minus 7. So b value is minus 7 to that value there. And then question number 10. Now we are solving question number 10 now. The equation of this curve x cube plus 3x square y minus y cube is equal to 3. Is equal to 3. You have to show that dy by dx is equal to x square plus 2xy divided by y square minus x square. And then find the coordinates of the point on this curve where the tangent is parallel to the x-axis. Tangent is parallel to x-axis, and you are going to find out the points there. We know that for this it is an implicit equation there. So we are going to find out dy by dx first. So x cube derivative is 3x square plus 3 as it is. Here the product rule will be used. So y as it is into 2 of x plus x square as it is into dv by dx, sorry, dy by dx minus 3y square as it is into dy by dx is equal to 0. So this will become 3x square plus 3 into 2, 6xy plus 3x square dy by dx minus 3y square dy by dx is equal to 0. Now these two terms are containing dy by dx, and we will shift the rest of the things to the other. So it will be left there 3x square minus 3y square into dv by dx is equal to minus 3x square minus 6xy. So here dy by dx is equal to minus 3 is common. So it should be x square plus 2xy divided by 3x square minus 3y square. So this will become minus 3 into x square plus 2xy divided by 3 is common. It is x square minus y square. Here 3 and 3 cancel. So this will be equal to minus x square plus 2xy over, because they are asking it should be y square first. So we can take minus 1 common and it will become y square minus x square. Because in the denominator it is x square minus y square. So you are taking minus 1 as common, so it will become y square minus x square. So this and this, that is going to be cancelled out. So finally, dy by dx is equal to x square plus 2xy over y square minus x square, which is the proof of this first part there. Then B part, the tangent is parallel to the x-axis, find the coordinates. Since we know that dy by dx, when it is parallel to x-axis, then we put dy by dx is equal to 0, because the slope of this x-axis is equal to 0 there. So you put this thing is equal to 0. So it will be x square plus 2xy over y square minus x square is equal to 0. After cross multiplying, so x square plus 2xy is equal to 0. X is common, so it should be equal to x plus 2y is equal to 0. So x is equal to 0 or x is equal to minus 2y. Now, because we got the values of x, so we put into the it should be, if x is 0, then in this equation number 1, 0 cube plus 0 minus y cube is equal to 3, or y cube is equal to minus 3, or y is equal to minus 3 cubic root. So one point is this, and the other point is when x is equal to minus 2y, then this one will implies that minus 8y cube plus 12y cube minus y cube is equal to 3. This is 3y cube is equal to 3, or y cube is equal to 1, or y is equal to 1. So when y is equal to 1, then next is minus 2y. So that is minus 2 into 1, and that is minus 2. So the other point is there, that is minus 2 and 1 for the final solution of this problem there. So this is the whole paper we have solved for A2 levels there.